Once again, I want to welcome you to the most important aspect of regression. The purpose of regression is to do two things: establish the causal relationship between a dependent variable and multiple independent variables. And the last time, we have seen certain things that we need to find out from the regression. One of them is determining which of the regressors are statistically significant. We indicated that in order to do that, you got to use the p-value. The p-value is the actual error that you make. And how do you use the p-value? Well, when you check the results, okay, like you see here, you check the p-value, which is the last column. If the p-value is less than or equal to 5%, it means that the independent variable is statistically significant in influencing the dependent variable. So we were able to indicate that price, the p-value is 5%, and therefore price is statistically significant. Complement price, we're able to see that complement price is 0.01, which is less than 5%, and therefore is significant. Income, we saw that income is 20%, correct to 2 decimal places, and therefore is insignificant. Location urban is 19%, which is less than 5%, and therefore is insignificant. And then religion Muslim is 0%, and therefore it is insignificant. It's significant. Okay. We're also able to establish that when the stars are 3 stars, it means that the independent variable is significant at 0.1%. 2 stars means that it's significant at 1%. 1 star is significant at 5%. And then when it is a dot, it means that the independent variable is significant at 10%. So we're able to establish that. Then we went ahead to determine the joint significance. We said that if you want to determine the joint significance, you've got to use the p-value of the F statistic, which is at the bottom here. The p-value of the F statistic, as you see, it is 2.2 e minus 16, which means that there are 16 zeros before the 2. And that means that it's approximately 0, which is less than 5%. And therefore, the independent variables are jointly significant. Now, we also find out how you determine the reliability or the fitness of the regression model, the suitability of the model. Okay. If the regression model is suitable, the R-square will tell you that it is bigger than 50%. On average, according to Hare et al., 2005, if the R-square is 50% or more, it means that the regression model is well fit. Now, some people bring it low, some take it up. And the R-square is actually the coefficient of determination. It tells you that percentage or the fraction of the variability in the dependent variable, which is caused by all the independent variables. And in this case, our R-square was 99%, which means that 99% of the variation in the quantity demanded of gene bitters has been fully explained by all the independent variables. Yes, Benedicta.
Hello, Doc.
Yes.
Please, I don't know if I'm the only person, but I can't see your screen.
Okay. Guys, if you can see my screen, please type yes. If you cannot see the screen, type no. If you can see, yes. If you cannot see, no. Benedicta, you can see the answers? Some say yes, some say no. So, what is happening? Some say yes, some say no. Okay. So, let me just do something very quickly and then see whether we can see it again. Okay, jolly good. We are good to go. Now everybody can see the screen. So the R square was an important variable that helps you to determine the suitability, the reliability of the model. The difference between the R square and adjusted R square, we said, was that adjusted R square penalizes the inclusion of irrelevant variables. And so it is always lower than that of the R square, or at most equal to that of the R square. So we've been able to see that the R squared helps you to determine a percentage impact of the independent variables on the dependent. It's not an F statistic. The F statistic helps you to determine the joint significance, not the percentage importance of the independent variables. We also looked at how to interpret each independent variable. We indicated that dynamic variables like price, when you're interpreting them, you got to interpret them as if they are rising and falling because they are dynamic. Then dummy variables or categorical variables, when you're interpreting them, you got to do it as if they are static because they are dummies, they are statute. So, for example, if you're interpreting the coefficient of price, okay, if you go to the data and you're interpreting the coefficient of price, the coefficient is negative 3.15, correct, to 2 decimal places. So you start with an average, convert the p-value to 0.05, 2 decimal places. And then you say that on average, given the complement price of gin, average income of the people, location of the shop, occupation, and religion of the people, a 1 unit increase in the price of gin reduces the quantity demanded of gin bitters by 3.15 units. It's a dynamic variable. So you got to indicate that a 1 unit increase in 8 cuts the quantity. Why reduces? Because of the negative sign. If it is positive, then a 1 unit increase will also increase the quantity demand. But if you are interpreting a variable like religion Muslim, what it means is that that variable is a dummy variable. And because that is a dummy variable, the way you interpret it must be as if it is static. So you indicate that you hold the other factors constant. What are they? The other factors are P all the way up to religion Christian. And so you now say that on average, given the price and complement price of gin, average income of the people, location of the shop, and the occupation of the people, quantity demanded is predicted or expected to be 23.01 units less if the people are Muslims than Buddhists. The reason why I use Buddhist is because Buddhist is a reference category. And anytime you're interpreting it, you got to have that reference category. Very good. So you got to learn how to interpret categorical and numerical variables. It is crucial that you are able to know all of this. At this stage, if you have a question, you let me know. Other than that, we are going to continue from where we left off the last time. Today, we are going to learn how to specify the regression model. Specifying the regression model is different from writing the estimated regression equation. What do I mean by it's different? Because when you are writing the estimated regression equation, let's say for a simple regression, specifying the model looks like something like this. Q beta naught plus beta 1 price plus the error term. This is a simple regression specification for a model. Why simple? Because the independent variable here is only 1, and that is price. But that is the specified model. It's not the estimated equation. If it is the estimated equation, what you got to do is to replace the beta parameters. Replace these betas with numbers, and everything else will stay the same. And then the error term will go. You don't bring it. Because one of the assumptions of regression is that the expected value of the error term must be 0. The assumption of 0 mean and a constant variance is well known. So because of that assumption, the error term is no longer there. So the only thing you're going to change is the beta naught and the beta 1. How do you change that? You change that by going to the result. Where is the result? This is the result. So when you go to the result, you see the names of the variable. These are going to represent the betas that have now been estimated. That's why you see them as numbers. Okay. Now, if you are specifying the model, you have these betas. But if you are writing the estimated equation, you don't have the betas. You change the betas to numbers. So what number is beta naught? Who can tell me? What number is beta naught? So you write a kill again, and then instead of the beta naught, you change it to the number. What number is beta naught, Steven?
Yes, Doc. It's 280 approximately.
Okay, correct to 2 decimal place for me.
Okay, 280.10.
0.27. That's
0.27. Okay.
All right, so you always have to convert it to 2 decimal place. Please take note. 280.27. That's what you write. And then you go to check the price, which is the beta 1 coefficient. What is the beta 1 coefficient here? Who can tell me? What's the beta 1 coefficient? Okay, so some of you are writing the answers down. Yes, Steven.
No, please 3.15.
Okay, it has to be negative. So it's negative 3.15.
Yes, please.
Then you add the price. So this is the estimated regression equation. It's the same as the other one above, which is a specified model. The only difference is that, well, the differences are 2. 1, the beta parameters have been replaced with numerical coefficient, and 2, there is no error term. There is no error term. Okay. If you don't understand, you let me know. If you don't understand, can you hear me? Can you hear me? Okay, I'm sure you can hear me now. Let's go to how you can now formulate the regression model for the whole program, for the whole regression. How would you have formulated it? Remember, specifying the model for the entire cross-section model. Who can walk us through that? How do you do the complete formulation for the specification of the model? Not writing of the equation, but then the specifying of the model. Who can tell us? How do you do that? How do you specify? Okay, so this is how you go around it. You have to now replace each of these estimates with their betas, starting with the intercept, which is beta naught. Okay. Don't bring the numbers, just the betas. So the intercept value of 280 is beta naught. The price value of negative 3.15 becomes plus. Even though it's minus here, you still make it plus because you are specifying the model. And you don't know how it will turn out numerically until you've specified. So it's all going to be plus, plus, plus. So this is going to be beta 1 for the price, beta 2 for the complement price, beta 3 for the income, beta 4 forever, like that to get to beta 8 for the real Muslims. So this is how you specify the model. You can see it. And then you add your error term at the end. Now, one important thing you want to note is that you have to expect to write exactly what you see in the result. For example, if you look at the result, okay, what I see here is P. And so because it's P, you don't go and write price. You write P. It is C, so you write C. It is M, so you write M. It is Loch Urban, so you write exactly as it appears, Loch Urban. You don't go and write location urban. Neither do you have to write LU. Neither do you have to write L. Okay, you write exactly what you see. Exactly. So religion Muslim, you don't write religion Muslim. You write real Muslims. Exactly what you see in the output. So you use the output, the regression result, to help you to specify the model if it was in an exam situation. If it was a thesis you are writing by yourself, you got to assume the all names you want to use to represent or formulate the model, and then give the details. So this is how you specify the regression model. Never forget the error term. Any regression model specified without the error term is wrong. This is always 8 marks, but you get it all wrong, unfortunately, if you do not bring the error term at all. Don't forget the error term. Any question? Don't forget the error term. Now that you've specified the model, the next is to write the estimated equation. You write the estimated regression equation. How do you write that? Well, it's simple. First, in the estimated equation, you don't need the error term, so that's never going to come. Second, the names of the variables, the P, the M, and all the others that are there are supposed to remain exactly how they are. Third, only the beta parameters will change. Only the beta 0, beta 1, beta 2, because they have their numerical values correct to 2 decimal places in the regression results here. And so yours is to just write the model, just write the equation, just like you've done for the model, just only replacing the beta parameters with numerical coefficient and excluding the error term. Who can walk us through that? How do you specify, how do you write the estimated equation? Who can do that for us? If you can do that, raise your hand for us and let's see, if you can help us. How will you do that? Let's, Stephen.
All right, Doc. Thank you very much. So with this one, we always have the
We are listening.
the
It looks like I'm losing you.
that's the Q, that's the dependent variable on the left, on the left. So Q is equal to, now we have 280.27 and then minus 0.11 C minus 0.98 M minus 5.11 log.
Okay. Very good. So this is how you write the estimated equation, exactly as it appears in the model. This is it. Now, the way you write this estimated equation is very important, ladies and gentlemen. Yes, Freeman.
Yes, Doc. Please, my question is on the subscripts.
Yeah, you can choose to bring them for my purpose or choose not to bring them. But the subscript actually indicates that this is a cross-sectional formulation. It's not panel data. So when we get to panel data, you see that we switch between I and T or combine. So the I stands for individual observations. Individual observation. So that is price for each shop. So I here is dealing with the number of shops in this case. All right.
Okay, thank you.
Any other? Okay. So the next thing you want to do now, and I want you to, all of you, write this specified model. Sorry, the estimated equation, write it down. Write it down in your book, in your notes somewhere, because we are going to use it for something crucial. And because I will not come back here, I would want you to please document this down. Write it exactly as you see down. This last bullet, write it down. The reason is because it is this same estimated equation that you use to predict. Two things that regression are meant for. One, for establishing the causal relationship between multiple variables. And two, to predict a phenomenon. So we use a regression to do prediction. And to do the prediction, it means that you must have already known your estimated equation. And our estimated equation is this very one here. That is why I want you to bullet that. I mean, to write it down before I move away from here. We'll come back to that when we are now trying to show you how to predict. Other than that, let's go to one more thing before we go to prediction, which is our last thing. I've already said it. Okay. One more thing before we go to prediction. And that is, okay. Let's do the prediction before we go to the next thing. So I've indicated some points here. Come on. I've indicated some point here that once your model is built and validated, and there are several ways you can use to validate the model. If you are using a Python, there are several things like ROCC and other things that you can use. R square is normally used as well, adjusted R square, MAPE is also used, and several other things. But once you've done the validation, you can now use the estimated model to predict the quantity demanded of gene vectors. So let's look at it. If I know the actual value of the price, let's say the price is 20. If I truly know that the actual value of the price is 20, the complement price is 100, the income is 200, okay? And I actually know that the location is rural and not urban. And I actually know that the occupation of the people is not teaching, is not trading, but it is fishing. It is fishing. Now, if it is fishing, then it means that occupation teaching will be what value? You can tell me. If it is fishing, it means that occupation teaching will be equal to what value? Christian. Yeah, Christian?
That going to be 0.
Exactly. If we know that the people are fishers.
Yeah, it will be 0.
Good. Then the occupation value will be 0. If we know that the people are fishers, then the occupation teaching will be 0. Take note. Now, how did I mention the fishers? I know fishers because fishing is part of the reference category. Don't forget. If I know that the people are Christians, then religion Christian will be what? If I know that the people are Christians, then religion Christian will be what? You can tell us. Then religion Christian will be what? It will be 1. Okay, Prince, you just wrote the correct answer. Religion Christian is going to be 1. Okay, and in that case, religion Muslim will be what? And in that case, religion Muslim will be equal to what? 0. Very good, Pakosi and Esuma. So that's how we are going to use that principle to handle prediction. Okay. So let's go to a scenario. I'm going to give you two scenarios here. Two separate scenarios. Scenarios. Okay, so take note. First one. Scenario number one. Compare the predicted quantity demanded. So we want to know the value of the quantity demanded, kill. We want to know that value of a situation. And what is a situation? Compare the predicted quantity demanded of gin bitters, which was made by some Muslim traders in an urban area. So that's the first scenario. We know that the people are Muslim traders in an urban area. Now, he says compare that. Let's call it K1. Compare that K1 with that of the gin bitters, which was rather made by some Buddhist fishers in a rural area. So in the second scenario, this quantity that we are looking for, let's call it Q2, was made by Buddhist fishers in a rural area. It's different from the one made by Muslim traders in an urban town. Given that in both situations, the gin bitters cost 15 cedis. The complement price costs 15, and the income of the people is 20. So this is prediction is 19 marks. Okay, you can't miss it. So how do you do that prediction? Okay, how do you handle it? So you have two scenarios. Scenario one, we need to find the value of kill. Scenario two, we also need to find the value of kill and then compare them. Which two scenarios gave a better quantity demanded? Now, let's get a sense of our equation. So this is where you have to fill in your equation. So look at our equation that we have. The equation we have had all along is this. The equation says quantity demanded is 280.27 minus 3.15p. Now, in the first scenario, actually in both scenarios, what was the value of the P that we were given? What was the value of the price? Who can tell us? It's in the story. You can raise your hand, you can give me the answer. It's the best way. Okay. What is that? Some of you are yet to learn how to use Zoom, so you are not raising your hand, even though I know you may have the answer. Okay. So the value is 15. Good. So price is 15. We are also told that the complement price is what? It is also 15. We were told that the average income of the people was what? It was 20. Now, remember, in the first scenario, the people were Muslim traders in an urban area. Don't forget that. Muslim traders in an urban area. So what do you think is going to be the value of location urban? What will be the value of location urban given this situation? What will be the value? Prince says 1, and it's true. So the value of location urban will be 1. We were told that the people are Muslim traders in an urban area. So what will be the value of occupation teaching? What will be the value of occupation teaching? I'm looking at some of your answers. Occupation teaching, that will be 0. Okay. Occupation teaching will be 0. Occupation trading will be 1 because the people are Muslim traders. And because they are traders, occupation trading will be 1. They are Muslims, so religion Christian will be what? 0. And religion Muslim will be what? What will be religion Muslim? Religion Muslim will be 1, just as Jones has indicated, because the people are Muslim traders. So now that you have the values for each of these variables, the actual values, you can substitute them into the model and find the value of K1. Find the value of K1. Who has done that? I've just given different acronyms for some of the words so that they are short. Yes, Samuel. Sammy? Samuel Yeboah. You can unmute yourself. So this is a substitution that we just did together.
Okay.
Yes.
It's 141.2.
Okay, you got to use your calculator and check it one more time. What will be the value of the quantity demanded? No. Samuel, your answer is not correct. The rest of you, if you are not punching your calculators, punch them. Follow me. I could give you the answer easily, but if I give it to you, it might not help you to cogitate and give a correct answer. So up here is a substitution. When you substitute all the values as you have here, what will you get? Okay, so you are going to get a value of 137.03 approximately. That will be the quantity demanded if you substitute. Let's go to the second scenario. The second scenario, we were told that the price is still going to be what it was. Okay. So because the price is still going to be what it was, we just substitute. Price is still 15. Complement price is still 15. The income of the people was still 20. You can check the story preamble. And we are told that the second scenario, the people are Buddhist fishers in a rural area. Let me write that down. Buddhist fishers. Buddhist fishers in a rural area. So what would be the value of location urban? You can tell me. What will be the value of location urban?
It will be 0.
It will be 0. Very good. What will be the value of occupation teaching? Mohammed.
0, please.
It will be 0. What will be the value of occupation trading? Occupation trading.
Also be 0.
It will be 0. What will be the value of religion Christian? Zero. Good.
0.
What will be the value of religion Muslim? 0. And that is because the people are Buddhist. So you can substitute all of these and then find the final answer for the quantity demanded. You substitute and find the final answer. If you do that correctly and respectfully punch your calculator, the answer you're going to get is 211.62 approximately. 211.62 approximately. So in both scenarios, we now know the quantity demanded. Remember that the first scenario, the quantity demanded was Q equal to 137, and this is 211.62. Which one is bigger? Scenario 2 is bigger. By how much? Okay. Scenario 2 is bigger, but by how much? So this is how you document it. You say that in this case, the quantity demanded in the second scenario is 74.59 higher than the first scenario. I've taken the difference between the two. So what was driving the difference? That was the next part to the question. And by the way, you have this in your assignment and also in your exams. What was driving the difference? Because remember, they all had the same price. And note that price could have also been different. But in this case, they all had the same price. They all had the same price. They all had the same price. They all had the same complement price. They all had the same income. They all had the same everything. So what's the difference? What was driving the difference? What was different between the scenario 1 and scenario 2? Who can tell me? What was different? What was different between scenario 1 and scenario 2? Okay, so somebody said the first difference is the location. Remember that in one case, the location was urban. In the other case, it was rural. So the location caused a difference. What else? Apart from the location, what else also caused a difference? Parkwesi says religion, occupation. Okay, so it doesn't mean that all the time the categorical variables must be the ones to cause the difference, and the numerical variables will be the ones that wouldn't cause the difference. That's a lie. In most cases, the difference is being caused by several other things. And that is how you are able to determine what causes the difference. Just check. For example, if the price was 15 for one and 300 for the other, obviously, price will be part of those factors causing difference. You can find several things and put everything in a beautiful table, and you can check whether the residuals are truly zero, looking at the regression. All right. So that is how you look at this whole picture of regression. That's how you look at regression. Now, how do you determine this? Because there's a next aspect to this whole regression question, and it is this. It says the variables that you selected to be multicollinear. Okay, we are going to go to that. So who can tell me the definition of multicollinearity? Let's get that first. Okay. Who can tell me the definition for multicollinearity? Who can tell us? Multi or multicollinearity. Yes, Steven.
All right, look. Multicollinearity exists when two independent variables are so highly correlated that it becomes very difficult to separate the partial effect of one from the other than the dependent variable.
On the dependent variable. Good. Okay. Yes. So let's try to understand some few things here. Multicollinearity. Two independent variables, they've got to be highly correlated. That's multicollinearity. And we selected those variables from the last time. Yes, Imanolodum. Okay, we selected those variables from the last time. Let me just remind you of those variables that we selected to be multicollinear. Who can tell us the top three variables, the pair of the top three variables we selected to be multicollinear? Who can remind us? The top three variables. And you do that by checking only the independent variables column. Only the independent variables column. Who can tell us the first pair? Stephen.
Okay, Doc. That is price and then OTR, P and OTR, 0.76.
Excellent. So that was the first one that we selected. In case you didn't know, this is it. What was the second pair? What was the second pair that we selected? Come on, give it to me. Who is serious with me? Naja. Yeah, Mohammed.
So it's between income, and religion Muslim, which is negative 0.75.
Negative 0.74 should be the right one. Should have been the right one. It's price
74,
and
yes,
complement price.
Price and okay.
That should be the correct one. And what was the third one? Please, who is talking a lot there? Okay. What is the third one? God's way. What is the third one? God's way, Nathan. Okay. So, all right. So the third one is negative 0.73, which is RM and M. These variables were selected to be multicollinear. The question now is that when two variables are multicollinear, one of the things that you can do is deal with it. The last resort may be removing one of the variables from the model. I want to repeat that. The last resort may be removing one of the variables from the model. Okay. So in this case, you have to check each variable and then remove it. One of them, one of the pairs. So remember the first pair was price and OTR. The second pair was price and complement price. And then the third pair continues RM and M. Now, so you must know something about each of these independent variables. You must know their variance inflation factor. Write that down. You must know their variance inflation factor. What is that? What is this variance inflation factor? Because the variance inflation factor is the factor by which the independent variables are inflated. Okay. The independent variables are so inflated. It tells you by how much the variance in the coefficients is inflated by the just by the fact that they are multicollinear. There's a formula for calculating the variance, but there's an easy way to find the variance inflation factor. Okay. Remember that there's always a connection between the variance inflation factor and the R square, as you can see here. So you need to find the variance inflation factor for each independent variable. And then you put it here. Now, fortunately, in an exam situation, I will find the variance inflation factor for you and rather ask you to use them to answer your questions. But in your assignment, you got to find it yourself. Okay. Yes, Mohammed.
Okay, so please, the multicollinearity, what are some of the problems that it can cause in a regression model?
One of the problems it can cause is that it can cause the independent variables to be less significant. It can make some of the independent variables insignificant.
Okay.
It can also have an effect on the value of the R square. On the value of the R square. And sometimes when they are perfectly correlated, it means that you wasted your time for collecting a particular variable. So it can simply make your entire regression sometimes unreliable completely. And that is why you must deal with it. And you use the variance inflation factor to deal with it. But you can also live with it by doing nothing to it, to the variables that are multicollinear. So you need to find the variance inflation factor. How do you do that? You do that by invoking a library called car. And then using that car, you type a double semicolon and type VIF. The name of my data was gene multi. So in your case, if yours is a COVID something, Okay. And then you wrote R covered or something covered. That's what you're going to use. The same one you use to write your regression. You do that, and then you run it. When you run it, you're going to get interesting results for the variance inflation factor. The result you get is a little bit funny, to be honest with you. It will not give you some of the scores. That is if you are doing an assignment. But if it is an exam, I will give you all of it. But if you are doing an assignment, it will not give you the breakdown of the dummy variable, the levels of the dummy variables, the breakdown. Their variance inflation factor, it won't give you. And when it doesn't give you, there's a reason. There's a reason. So for the dummy variables, some of them will not be given. Okay. But for others, they would. Let me just see if I can run this variance inflation factor I'm just talking about here. Just so that you are able to have a feel of what we've been discussing all these while. Because sometimes some of the things that we discuss, if you are not feeling it, the whole time I sound like Hebrew. It's either sounding like Hebrew or Aramaic for you. So what we can do is that I can show you how to estimate for some of them. So if you are ready, let's try. Let's try to estimate some of them. So I'm just going to go to one of the data and show some of the results. Please, if you can see the R command, let me know. If you're able to see the R command, kindly let me know.
Yes, Doc.
You can see it?
Yes, please.
Lovely
Yes,
job.
Doc, you can see it.
Okay. So this is the R result. After you run your regression, you can go to the command and invoke something called library car. I told you earlier. Okay. Library car. So this is it. Run library car and then run car VIF, the name of the model. This is what you have. You have something known as the GIF. It's the first one that is important. I told you that the GIF for the categorical variables will not give you the details of the levels. So you don't have log urban, you just have log. You don't have OC teaching, OC trading, you just have OC. Therefore, one rule that I want you to take note here is that dummy variables are not sensible to be handled by their VIF. In other words, you cannot use the VIF of a dummy variable in any way to judge whether the variable must be included or must be removed. Why? Because the fact that it's a dummy variable means that it's not changing in any way. And so and multicolinearity looks at how the changes between two variables are correlated. How the two variables are correlated. And dummy variables are not changing. And so when you go and calculate their variance inflation factor, it's meaningless, econometrically speaking. It's meaningless to use to judge on that. So what happens when the variable is a dummy variable? What happens when one of the variables that you are trying to see whether it must be deleted or it may be deleted? What will you do with that variable? Now listen, please. If that variable is a dummy variable, ignore it. And in this case, for the purposes of exams, in this case, you just indicate the numerical variable that is the one that may be deleted. So let's take our first numerical variable, our first multicollinear pair. If you can remember the first pair, you can remind us of the first pair. The first pair, if you could remember, was price and
OTR.
Okay, so price and OTR. The question is that which one may be deleted? Check their VIF And you will notice that OTR is not in the occupation training. It's inside it, but it's not shown on its own. So in this case, you will only judge the price. And when you judge the price, judge it and ensure that it is 10% or more before you say that it may be deleted. Okay, so check the price, check its VIF, and if the VIF is more than 10, then it may be deleted. So let me ask you, between price and OTR, which one may be deleted now? You can tell us. Between price and OTR, which one may be deleted peacefully? And of course, why? Which one may be deleted and why? Thomas.
Price, sir.
Why?
Because it's more than 10.
What is more than?
The VIF.
The VIF, okay. The VIF is more than 10. And the VIF, which is 24, you got to mention the actual value. The VIF, which is 24, is more than 10, and therefore it may be deleted. Now, the next one was price and complement price. Which one may be deleted and why? Which one may be deleted and why? Let me see. All right. So in this case, if you check complement price is 10.38. Okay, and you check price is 24.15. So price may be deleted because it has a higher, the word is that higher VIF than that of complement price, and therefore it may be deleted. Okay. Now, I'm just comparing the two. That is why you choose the one that is higher. Okay. Now, the last one are dummy variables, okay, RM and M. RM and M. If I asked you which one may be deleted, okay, RM is a dummy variable, so you can't touch it. It's meaningless. M, you go and check M, and its VIF is 10.81, which is more than 10, and therefore it may be comfortably deleted. Now, this may be comfortably deleted. It's not guaranteed. It's not guaranteed that you got it deleted. No, but it may be comfortably deleted. So what if the variables were all categorical? If both are categorical, let's say RM and OTR, they are both categorical. What do you think you would have to do? You can tell me. If both were categorical. Now, if both are numerical, we know that the higher VIF one, the one with a higher VIF may be deleted. If it's one is numerical, one is categorical, you don't touch the categorical, you touch the numerical. And you check if it is bigger than 10, then you can guess it may be deleted. What if both are categorical or dummy? Who can tell me? If both are dummy, what do you do? What do you do if both are dummy variables? Benedicta, are you here, Benedicta? Benedicta Edinam, are you here? You are the one who says I don't see my screen.
No, please, I'm here.
You are here. You know when you said you didn't see my screen, okay, I responded. Now I'm asking you a question, you are quiet. Is it because you're not paying attention? You got to pay attention, guys. You got to really pay attention. Okay. All right,
Yes,
so
sir.
none of them has to be deleted. Okay, go and find out why. Find out why. It will be a joyful thing for you. All right. All right, so ladies and gentlemen, that brings us to the end of the entire caboodle. It's been a very refreshing lecture for you. Go and watch the rest of the video, look at the notes, enjoy it. If you have a question, I'm right here for you.